Okay, so we're going to continue 1.4. We need to finish off the notes by talking about the trig functions. Now, in a trig function, let's think about the sine curve. The sine curve goes on forever and ever in both directions. It does not pass the horizontal line test. So for it to have an inverse, we need to restrict it to only include certain values. So that's why the values were, the thing that's going to be most important is this chart right here. Okay, for a sine, we need to restrict it. We're going to go from positive pi over 2 to negative pi over 2 and any value in between. So we're not going to call, so because we needed it connected, so we're not going to use, normally we would go all the way to pi to get those, or we would go through the circle in a positive direction to get positive and negative values. For here, so that it's a one continual motion, we are going to go from negative pi over 2 to positive pi over 2. So the negative pi over 2 to 0, that's going to be where the sign is negative. And then from 0 to pi over 2, that's going to be where the sign is positive. Remember, the sign are the y values. So we're only going to look for answers to inverse trig functions in those two quadrants, okay? The positives will be in the first quadrant. The negatives will be in the fourth quadrant, but we're calling them negatives. We're actually calling them negatives. We're only going to stick in numbers between 1 and -1 because the sign's height is only between 1 and -1, okay? Now let's look at the ones that follow that same pattern. Cosecant. But what is cosecant missing? What value does it not include? What value does the cosecant not include? It doesn't include 0, does it? Why? Well, we can't take 1 over 0. It's undefined. So it's going to be the same exact values we're thinking about. The answers are going to be anything from negative pi over 2 to positive pi over 2 without 0. 0 won't be included. Since tangent is sine over cosine, it's going to be the same exact things, but it will have open circles at the ends because that's where the undefined values are. So those ones go together. So sine, cosecant, and tangent, you'll be looking for answers in similar locations. The positives we call positive pi over 4, pi over 2. The negatives we would call negative pi over 4, negative pi over 2. So we're going to stick in a unit circle value, square root of 2 over 2, 1/2. And we're going to get out a, you'll notice the range is our radian measure. Okay, so this is the unit circle value. So this is unit circle. And this is the radian measure. So it's very important that you know that says radian, by the way. Okay. Okay, so those three go together. Now let's take a look at our cosine. Our cosine goes from 0 to pi. Now, why is that? Well, that's because we're going to get positive values from 0 to pi over 2. We're going to get negative values from pi over 2 to pi. We need that perfect connection that we get both positive values and negative values. So the cosine goes from 0 to pi. So let's think about the secant. It's going to be exactly the same. The answers will always be from 0 to pi. except one value will make it undefined, and that's pi over 2. That's where the cosine equals 0, and secant can't be 1 over 0. That's undefined. Cotangent, since it's cosine over sine, it will be defined everywhere except where the sine is equal to 0. So that's why you're going to look for numbers for the cotangent between 0 and pi, but we won't include 0 and pi. So cosine, secant, and cotangent go together. Sine, cosecant, and tangent go together as far as what values we're looking for on the unit circle. We're looking for the radian measure on the unit circle. Go between pi over 2 and negative pi over 2 for the sine, the cosecant, and the tangent. Look for values between 0 and pi between, or for the cosine, the secant, and the cotangent. Now, you're not going to have to really have those memorized. If we have inverses on any quiz or test, I'll probably put a little chart like this up on the board so you have it, but you need to know how to use it. So just so you're aware, let me take a picture of this myself. I always forget these values myself. So if I don't memorize it, then I think, well, yeah, you probably won't either. Okay. So now that we kind of have a selection of values to look for, let's talk about what an inverse does. Okay, so let's think about when we use the sine of something. We're always sticking in a radian measure. What's the sine of pi over 4? And we get out a unit circle measure, square root of 2 over 2, right? So what does an inverse does? It switches them. So let me show you what I mean. So if we do y equals the sine of x, this is your radian measure. This is your unit circle value. Okay? An inverse trig function will be denoted with that little -1 symbol. And its points, this is your unit circle value. So they say, I found an inverse sine of square root of 2 over 2, and this would be the radian measure that would match pi over 4. So the answer to an inverse trig function is the radian measure because it turns those values. So now we're thinking backwards on the unit circle. So we are thinking backwards on the unit circle. So as long as you can go backwards and think, oh, hey, what radian measure did that? Remember, the answer to a inverse trig function is what radian measure did that? And then we only have to look in 2 quadrants, either between positive pi over 2 and negative pi over 2, or for a cosine between 0 and pi. Okay, so we only have to look in two different quadrants. So let's just do some of these. Okay, so we have some problems here that are inverse trig functions. Okay, so let's look at our first one. So let's see what this is saying. This is saying what radian between for a sine, that would be negative pi over 2 and positive pi over 2, has a unit circle value of negative square root of 3 over 2. Now, what's great is if the answer is negative, you know our thing is negative. So you just have to think, where is the sine square root of 3 over 2? Well, the sine is square root of 3 over 2 at 60, which is pi over 3. So this is just negative pi over 3. So sine and cosine are actually, sine is actually the easier one, because if the answer here if you're thinking of something negative, the answer is negative. It's just the negative version of it. So it's actually nice. Okay. Let's look at B. Now, this is what's cool, I guess. Here, that's going to give us a radian measure, but then we're just going to undo it. So our answer will just be the thing inside. Because if I say, hey, what radian measure gave me a tangent value of -1 over square root of 3, and you say negative pi over 6, and then I say, hey, what's the tangent of negative pi over 6? You're going to say -1 over radical 3. So if these two things are exact opposites, they reverse themselves and go right back to what it started with. So they're inverses. The x becomes the y becomes the x. Remember that? That's what we learned about inverses anyway. So the same thing should hold true here. So that would be 5 pi over 4. Now D is different because those things aren't perfect matches. Okay, so let's look. The cosine of 2 pi over 3 on the unit circle, just think of 2 pi over 3 is 120. What is the cosine of 120? Well, that's the x value at 120, which is -1/2. And now just go backwards. Where between negative pi over 2 and positive pi over 2, where is the sign -1/2? Well, it's going to be negative. That's what's great about the sign. If it's inside is negative, then your answer is negative. And where is the sign 1/2? That's going to be at 30 degrees, pi over 6. Okay, so you just have to reverse your thinking on the unit circle, and you only have to look in 2 different quadrants for the sign between positive pi over 2 and negative pi over 2, for the cosine between 0 and pi. So you're just reversing, going backwards. If this is the answer I got, what unit circle value, what radian measure gave me that? Okay. Does that make sense? Does anybody have any questions about that? Okay. So you have an assignment down there. So please work on that assignment now in class. Check the date that I have in Google Classroom. I'll tell you when it's due. Tomorrow, we may start 1.5. I'm not sure yet. I'll take a look and let you know. But you have the rest of class to work on this assignment.